Hello everyone, welcome to SkillSpotlight, a youth-led workshop series with the Skills to Sustain program hosted by EnvironBuzz magazine, which is an initiative of the EnvironFocus Incorporated. Today's workshop focuses on geospatial data analysis and remote sensing. By integrating geographic positioning and traditional data, geospatial data analysis is able to reveal many different spatial patterns and trends on a global scale. Our other featured skill, remote sensing, means collecting data about an object, area, or phenomenon from a distance without any physical contact. So to help us explore this topic, we are joined by Matt Hallas, who is a Geospatial Practice Manager at DevGlobal. Hey Matt, welcome to the workshop. Would you like to quickly introduce yourself before we get started?
No problem. Thank you, Christian. Thank you, Scan, and it's nice to be here, everybody. My name's Matt Hallas. I manage the geospatial practice at DevGlobal. And what that means is DevGlobal is a technical consulting firm that helps with applied geospatial analysis, community building, all focused on supporting the sustainable development goals that the United Nations has laid out. So a lot of the work that we do is supporting philanthropies, intergovernmental agencies like UN agencies like UNICEF or WHO, as well as commercial companies, try and more efficiently basically complete the projects that they want to do utilizing satellite data. So we'll get into a lot more of what that actually means. But essentially, we use maps to help people make smarter decisions and to track how those decisions are actually playing out in the real world. And kind of geospatial technology, maps, locational intelligence, that's all a facet of how they can track and monitor progress against their investments and against kind of government initiatives.
Thanks Matt, it's great to have you here with us today. I'm very excited to dive deeper into your work in geospatial practice and explore how it's helping advance sustainable agriculture and strengthen food security around the world. Before we begin, here's a quick overview of today's session. We'll move through 3 learning layers. Learning layer 1, knowledge, is about understanding the skill. Learning layer 2, application, is about showing the skill in action. And learning layer 3, transferability, which is about how the skill can be applied across sectors. We'll wrap up with some key takeaways and a closing reflection. Today we will explore how satellites are helping farmers grow food more efficiently, how they're reducing environmental impacts, and building more resilient agriculture systems. We must first understand the basics of satellite technology, then learn how remote sensing works, and lastly, the role of data in modern agriculture. Hey Matt, so to get us started, could you tell us about how you use geospatial technologies for sustainable agriculture at DevGlobal?
Absolutely. So an important thing to note about geospatial technology is that it can be a lot of different things. So it's essentially data collected from a distance about the surface of the Earth. So we have satellites that can do that. There's drones that do that. You can put a camera on a plane. You can even put it on a helicopter. And all of those pictures and the different sensors that you have in the camera is essentially what a remote sensing product is. So when you think about it for sustainable agriculture, satellites have a really unique capability in the sense that they are global, right? They're orbiting the surface of the Earth. So you can image the same location on the surface of the Earth numerous times over the growing season. So you can utilize satellite data to basically over time assess how much crop area has actually been planted in a given area. So when you're trying to look at, sort of like commodities pricing, and when you're looking at food security, you want to, of course, have an initial understanding of, for example, how much wheat is going to be planted and then how much wheat is available for harvest. Because of course, huge countries are buying lots of wheat from different places or they're exporting it. That also applies to rice. So satellite imagery, you can basically use to understand in advance how much total area do we think we're going to have growing these types of core staple crops. And then throughout the growing season, you can monitor the health of those crops to then make a determination of how much yield, aka how much wheat, how much rice is going to be grown in an area. So a government, for example, they may grow 80% of the rice that they need for their own citizens, but that means that they're also trying to buy 20% of the rice to kind of make sure that, there's enough rice in the country as is needed. And satellites can not only help that government understand, okay, this year in 2026, are we going to hit that 80% number? So we know we just need to buy the 20%, or are we actually going to produce 90%? Are we potentially going to produce 50% because we had a bunch of droughts and we had, pest or disease that came in? Satellites and geospatial technology allow you to, in advance of these sort of considerations, start to get a baseline understanding of how much crop will be grown in a certain area.
Thank you, Matt. Using geospatial technologies to support data-driven decision-making for farmers is perfect when we're talking about sustainable agriculture, since it helps us to optimize the farming practice as a whole. My next question is about remote sensing. What exactly is remote sensing and how does it work?
Yeah, so the really funny thing too is like when you take a picture of your friends, that's technically remote sensing, right? Like you are sensing, you are taking a picture from a distance. And it's really like what that camera can take pictures of, so the sensors within the camera, and where you're taking that picture. And is that from a phone? Is it from a drone? Is it from a plane? Or is it all the way up in orbit looking down on the surface of the earth? So we as humans visualize the world in what's called, the visible spectrum of light. So we see basically between red, green, and blue, right? But there's a lot of activity, shall we say, that happens in the wavelength spectrums that humans cannot see. And that is when you get into the near infrared, the shortwave infrared, and beyond. That's where basically a lot of things applying that are related to vegetation, a lot of insight can be gathered from having a sensor that detects light in the near infrared and shortwave infrared that a human eye couldn't see, but a remotely sensed, a camera can see if it has the right sensors. And so when it pertains to agriculture, one of the big sort of regions of the electromagnetic spectrum is this near infrared spectrum, because you can really determine like the greenness of vegetation, but also potentially any stress on that vegetation. And when you're looking at a picture taken from a satellite, you can basically do different math on that image to understand where vegetation might be stressed, where you might have potential drought because there's not as much water in the soil or on the plants. And so remote sensing is this kind of, view from above that allows you to better understand what's actually happening at like the field level, the crop level, et cetera.
That was really insightful. It's fascinating that satellites can capture information beyond what our eyes can see and transform it into data that helps solve real-world problems. Lastly, I know we talked about how geospatial technologies can be used, but I would like to dig deeper on what types of insights they can provide and what makes them so valuable for farmers.
Yeah, I'll take a specific example from one of our partners, a gentleman named Femi. He's actually called Femi the Flying Farmer, and he operates a drone capture company, and he's based out of Nigeria. So what he will do, and his drones, that is inherently remote sensing, right? His drones will, for example, go over a farmer's field right in the few days after the farm has actually planted crops. Once the crops start to sprout, a drone is able to see much, much better resolution. Like you can see smaller things in the image from the drone because the drone is closer to the surface of the earth, right? Whereas a satellite, you're so much further, you can't usually detect like an individual crop from that satellite, but you can absolutely do that from a drone. So with drones, you can actually do what's called crop counting itself. So you can literally fly a drone over a plot of land, over a farm, and actually count how many, of these crops are starting to sprout. because the farmer will know, hey, I expected there to be 500, wheat crops in my field. But I don't know how many of those took. I planted them all. And as opposed to the farmer then having to go out and walk, his whole plot of land, you could use a drone to actually do that counting for the farmer. So normally a farmer, that takes an inordinate amount of time to be able to literally walk the fields, check on everything. Okay, is this region a little overwatered or underwatered? They don't maybe know why certain regions, the crop hasn't sprouted to the extent that the surrounding areas have. Remote sensing allows you, like I said, with the electromagnetic spectrum, to like see other things that the human eye wouldn't be able to identify. So a drone can count all of those crops and then also do these things called spectral indices, where you're basically again doing math within the image itself, where you're like, if the image has a near infrared band, you can add and subtract and divide that across some of the other spectral bands that it has to get a sense of the vegetation health or vegetation stress. So the crop counting plus those other indice layers can start to tell the farmer, hey, in this part of your plot, you expected all these crops to be at this height. The drone image is showing it's much shorter and it hasn't actually taken root as much. And as opposed to that farmer having to have walked the entire field to make that determination, the drone can actually like direct them more effectively. So instead of them taking a whole day or multiple days to walk the field, like they know exactly where to look. They walk out there and check it out themselves and they say, okay, yes, the sprinkler line broke and that's why it's not getting enough water. Or, hey, we planted these too close together and that's what's causing this issue. It could be many, many things, but essentially that technology can help make better use of the farmer's time.
Thanks, Matt. That was another great answer. More of what remote sensing can provide is helping to automate farming tasks like crop counting, which further supports sustainable and efficient agriculture. We can now transition into the application layer, where we'll focus on the skill in action. Here we will look at real examples of DevGlobal using technology for agriculture, how AI and geospatial technologies are used to solve sustainability challenges, and the process of how geospatial data is turned into actionable insights. So Matt, whenever you're ready, you can walk us through one of those examples.
Yeah. So here's a really good example. So we have a program right now with the Gates Foundation that is focused on improving outcomes for small scale producers. Small scale producers are farmers that typically have very small plots of land that they farm. These can just be a few acres at a time. And so the entire program is focused around how can we use artificial intelligence and geospatial technology to improve outcomes, aka improve the yield or improve economic outcomes for those small scale producers on the African continent and across Southeast Asia. So basically, right now in the agricultural space, there's a lot of mobile application advisory services. So it's literally a tool that you have on your phone where it's an application on your phone where a farmer would be able to log into this and say, when is the best time for me to plant my winter wheat crop? Or you can ask it a question that says, what is the right type of fertilizer to utilize for this winter wheat? That AI application should then basically have kind of an internal chatbot that says, based on this person's location, based on the time of year, based on weather data that we have, this is our recommendation of when you should plant that winter wheat crop. Oftentimes, so we are helping to basically, at DevGlobal, we are making sure that farmers are involved in the discussion of how those tools are actually designed. So that could be like a workshop where we work with farmers to understand, okay, give us the full list of questions that you'd want to be able to ask and get answered, right? Or tell us examples of previous times where you've received advice from an extension agent and it's actually been bad and hasn't helped you, and might have actually hurt your output of a specific area. So we do a lot of what's called requirements gathering and like stakeholder engagement to make sure that the right voices are in the room. Because oftentimes in global development, it's a bunch of people in Seattle, in Washington, D.C., in Geneva, Switzerland, making decisions for people in completely different areas where they've not actually talked to them and listened to them and tried to understand what they really need for a tool like that to be used and for it to help them. So our big job is to make sure that not only are they in the room, but their decisions, their discussions help to inform what the mobile applications are actually then deployed for. The process of transforming satellite and geospatial data into actionable insights, that's also the really complex part, because right now there's these amazing AI models that can map land use, land cover, that can map specific crops, that can map tree cover, that can map tree cover loss. A lot of those maps and huge models are built on data that comes from the global north, right? It comes from North America, it comes from the European Union, and the type of agriculture across the EU and North America and what you see in sub-Saharan Africa or Southeast Asia are vastly different. In the US and in the EU, we do monocropping. So you have hundreds and thousands of acres of a field that is planting one crop type, right? The EU does the same thing. Ukraine does the same thing. When you look at small scale producers and these individuals who are farming for livelihoods, as opposed to farming typically as like a commercial output, they will do multi-cropping. So they have numerous crops basically within one plot of land. What that means for geospatial is that if you have a model that was trained on fields that are only wheat or only corn or only soybeans or only rice, trying to apply that same model to an area where they might have all of those crops or those crops plus many others in the same plot of land, it's not going to work, because you're trying to have a computer identify things present in the training image that are not present in the real world image. And that's a big part of our role within the project, is to help to generate more localized training data sets so that the models that can predict like when to plant, when to harvest, what fertilizer to use, if all of those can actually be built more on the local geography, the local soil substrates that are there, the local climatic and meteorological conditions, that advice that's coming from the mobile application is going to be a lot more relevant and be a lot more accurate.
Very well said. I think that was a very interesting insight on how you use AI with geospatial technology for agriculture with the AI models, and the process you use to localize the training data to make them more accurate. Now we have a quick interactive activity for the audience. If you were managing a farm, what information would you want a satellite to provide you to help you make better decisions? I'll give you guys a couple of seconds to think about your answers. And now for our last layer, transferability, where we will see how the skill can be applied across sectors. We will explore the transferability of geospatial and data analysis skills, the emerging trends in Earth observation, remote sensing, and geospatial intelligence, and to conclude, some key technical and transferable skills that are needed for careers in geospatial technology and AI.
So the transferability, is vast. So something to keep in mind, and how I describe to my parents or others who, when I say I do geospatial, they say, what does that mean? Really, to boil it down, it's like, do you need to do something in a place at a certain time, right? And that is pretty much all of life. Like a logistics company, their entire job is getting materials from A to B. And satellites, you can think of oftentimes as a tool to enable logistical planning. So when I was talking about, farms and are we harvesting at the right time? Are we planting at the right time? Are we, fertilizing at the right time? Like those are all parts of a logistical workflow, right? You can apply the same concept to completely different fields. So the biggest field in remote sensing is defense and intelligence. So it's mapping military assets, it's mapping, other sort of things, and it's getting, materials from A to B. It's assessing potential risk. of an area. The transferability of geospatial moves far beyond that as well. Like cities and towns and governments, they also utilize geospatial to create what's called a digital twin. So a digital twin is like a 3D map of your city. Another good example is like most people use some sort of mapping application. If you're driving to a new place, you've never been there before, what do? You go on Google Maps, you go on Waze, you go on one of these tools, and you say, I need to get from A to B. The actual like infrastructure that's allowing you to do that is a GIS. It is a geographic information system. When you pull up Google Maps and you see the roads and you see the houses and you see the little rivers or lakes or whatever, all of those are data points within a massive geographic information system that allow you as the driver to say, I am home and I am going to, this arena, wherever I am going, this friend's house that I've not been to. Like, so the transferability we talked about in agriculture, like think about geospatial and GIS as how do I get from A to B, but also what's happening at A and what's happening at B, and how can I better understand like why these things might be changing. That leads into the emerging trends, because the emerging trends are vast. Like right now, geospatial and AI are at this really crazy, I wouldn't call inflection point, but lots and lots is happening, both on the remote sensing side itself of just like the sensors. So the emerging trends are we now have thermal sensors that are coming out. Thermal sensors, there's a great program called FireSat, where FireSat is basically going to be a constellation of 50 satellites that are specifically up orbiting the Earth to monitor wildfires, to monitor the spread of wildfires, also hopefully eventually to start to potentially predict where wildfires could occur based on, the underbrush, basically like the fuel that's present, dead trees, living trees, etc., as well as like wind patterns, soil moisture, all those things. So part of the emerging trends is that we have new sensor technology and we have a lot more data. So the cost of launch for satellites is way less than it used to be. So we're able to basically have a lot more satellites up circling the Earth, which means we can take more pictures throughout the day. And so with more pictures comes an increased ability to basically assess trends, both on like the day-to-day, the week-to-week, or months or years, right? So just more data being available in different wavelengths is a really awesome emerging trend. And then when you look at the artificial intelligence side of things, like you have these organizations who are basically trying to build tools that allow you to very quickly map something of interest. We, in the past at DevGlobal, we built a open source tool called RAMP, Replicable AI for Microplaning, that basically is an open source tool on GitHub that someone can come in and say, I want to map all of the buildings in this specific area, and I'm going to use a model to run it against my satellite image. When you do that, you run this image again, or you run the model against the image, you get an output of the total number of buildings. That total number of buildings can then directly inform things like vaccination planning. So then you have an understanding of like the baseline population count, or at least an estimate of an area where you might not have good census data. So the trend of basically being able to very quickly make sense out of lots of data and to incorporate different data types, that's what's really, really cool, is that right now there's models that will take in to account not only the standard remote sensing imagery of like an image of the surface of the Earth in different wavelengths, but it can take in socioeconomic data. It can take in that tells you market pricing for a specific crop type. And you could basically combine all of these data layers into a way so that in that mobile advisory service we talked about previously, it can make a more informed suggestion that says, based on everything here, based on the different remote sensing layers, the socioeconomic data, the meteorological data, like we actually think you shouldn't plant winter wheat at all. We think you should plant this crop, right? It could be cassava, because the market economics is saying you're going to make a lot more money if you're trying to sell cassava. Or we're planning there to be better weather patterns so that your yield of that crop type is going to be better. So those are the emerging trends. And then the technical and transferable skills, first and foremost, is curiosity. I would say secondarily, it's being interested in tech, like it is having a desire to learn about what different satellites do. Like why does Planet, for example, have so many satellites up in the air, and why does a company like Vantor only have a few? And the answer therein is complex, but it's because different satellite companies have different markets and different use cases. Just the simple fact that Planet can take pictures of the same point on the surface of the earth every day over a long period of time means that they don't usually carry the same like depth of sensor on board. But it's still a good, clear picture. So if you think about it, back to the transferability of skills, if a government is trying to pay for a massive infrastructure project and they're building a bridge or a railway network, you can use satellite data or other types of geospatial data to monitor that from afar. So historically, a government would have to send people out to this area, right, to monitor it and see it over time. A thing like Planet, you can actually just take pictures of that infrastructure project over time and you see how it goes. So a person, in terms of like people that want to get into this career, I would say an interest and a curiosity in like what is satellite data, and wow, it sounds like I could do it for agriculture or conservation or defense. Like just doing some research to say, okay, what else do I think I could see? Go on Google Earth, right? Google Earth is one of the best remote sensing platforms out there. It's free. You can look back through things over time. And the great thing, the last thing I would say, Christian, is like you don't need to be overly technical to work in this space. Yes, there are very, very technical aspects. I've worked with literal rocket scientists, multiple PhD holders who are designing the sensors, designing the data ingest and output systems and all of that. And those people are essential, but that doesn't mean that you have to be deeply technical. You don't have to be a developer. If you have this curiosity and you can start to kind of research and get involved in things like humanitarian OpenStreetMap, which are a great open source community built tool to map things for humanitarian purposes, that's really one of the best ways to start to get involved.
Thank you so much, Matt. Those were great answers once again. I think that's something that many people here can learn from, especially if they're considering going into geospatial. And curiosity being the main skill is an important takeaway for anyone starting out. Before we wrap up, I'd like to leave you guys with a reflection question. How could satellite technology help solve a sustainability challenge in your community? I learned a lot from Matt and his experience as a Geospatial Practice Manager, but if I had to simplify this workshop into 3 key takeaways, it would be that satellites collect valuable information about the Earth's surface without physical contact, allowing us to monitor changes over time, leading to more accurate, data-driven decisions. Artificial intelligence can process large amounts of satellite data quickly, providing accurate, localized insights that allow farmers to use water, fertilizer, and other resources more efficiently. Geospatial skills are extremely transferable and applicable to almost every sector as long as you are looking to do something at a certain place and at a certain time. Here's my final question for the audience. If you had access to satellite data, what agricultural or environmental challenge would you want to solve and why? I would like to give a big thank you to everyone who attended this workshop. I hope you've gained a better understanding of geospatial data analysis and remote sensing and the incredible impact these technologies can have on sustainable agriculture and beyond. If you'd like to continue learning about sustainability, be sure to check out EnvironBuzz magazine. And if any of you watching today are interested in learning more about geospatial practice and the work being done at DevGlobal, I encourage you to visit the website. Thank you again for joining us. My name is Christian Ogundipe, and it's been a pleasure hosting today's SkillSpotlight Workshop. Have a wonderful day.